All right, we're going to factor some more polynomials here. These won't be quadratics because they'll have higher exponents, but we're going to factor these things. All right, we're going to use all the tools that we've discussed. We have 3 different ones to do today. All right, first one. These 3 have a common factor. We should always look for a common factor. So we need to think, what can we pull out of all 3 of these things? First of all, they can all be divided by 2. They also each have an x squared. What would be left over? Well, it would be x squared. We would need a 2 here, so this 2 and that 2 multiplied to equal 4. We'd also have to write another x, so we'd have to say 2x. At the end, if we divided by 2, it'd be a minus 15 left over with no x squareds anymore. All right. From there, we need to see if we can factor what remains. So, for example, on this one, we have this quadratic here. We need to factor this into 2 sets of parentheses, and it'll look this way, just like we have been doing all week long and the week before. We need to figure out what 2 numbers multiply to equal 15 and add up to 2, right? Knowing that they should actually multiply to equal negative 15. The 2 numbers that would work would be these 2. See, the only thing we did in those 2 steps was rewrite that trinomial up above as a factor of 2 binomials. Okay, second kind of question. It's very similar. We're going to treat this as 2 separate situations. So we have this first group, the second group. Let's factor them separately, but in reality, it's part of the same question. All right, so for the first part, this yellow part. Oops. What do they have in common? What can I take out of each of these? Well, they can each be divided by 3. They can each be divided by an x. That will leave x left over and minus 4. For the green part, we can write that trinomial as 2 different factors. Same way we have been doing. All right, what 2 numbers multiply to equal positive 1 and add up to negative 2? These 2 right there. Well, this one gets tricky sometimes, but the only numbers that go into 1 are 1 and 1 or negative 1, the same fashion. What's your answer going to be? How do I write my answer? Well, your answer is, your answer is that whole thing. It's all of that. So your answer would look like that. The last kind of question you're going to see in this section is a throwback to the section we did about grouping. So if you see 4 terms in a question, I want you to think group. Grouping. So there's one group, there's another group. Let's break it down. What does the first group have in common? The first group has x to the third as a common factor. That would leave x plus 5 left over. The second group has 4 as a common factor with the same thing left over. Remember, when we use grouping as a technique, the same factor should be left over in each one. And to finish the problem off, we're going to say one of the factors is that common, x plus 5. And whatever's left over is our other factor. And that takes us through those 3 examples from this assignment. Remember, your assignment is factor higher degree polynomials. You have it.